In the final topic for this series, we will look at SON management in HETnets. Before going further, you need to understand the basics of inter-cell interference coordination (ICIC). If you haven't seen our tutorial, please do check it out. Link on the top right corner. Heterogeneous networks or HETnets have multiple definitions as we explained in one of our earlier tutorials. You can check it out. We will cover some of the topics from that tutorial here. A simple definition of HETnet is as seen in the slide here. Basically, you have different layers for macro cells and small cells. In an ideal world, each of these layers will use their own frequency and there will be no interference whatsoever, at least in theory. In practice, you can have RF harmonics, RF leakage, etc. that can cause issues, but we won't worry about those things here. What generally tends to happen in the real world is that operators have a limited amount of frequency, so they try and reuse the frequency wherever possible. Here you see the blue macro cell with pink border. The operator may now decide to reuse this frequency in some areas as part of small cells. This can cause radio frequency interference. Let's say we have a macro cell covering a large area as it should. Let's say there is a business park that is on the edge of the cell. They have poor coverage, so the operator deployed a micro cell here. Now let's say there is a factory. While there is good coverage outside, there is very poor coverage inside. This is because it's made of metal and the RF is unable to go from outside to inside. Here the operator has provided the factory with multiple picocells. You may have an office or shared work area with multiple femtocells. You might have a mall with couple of picocells. The challenge is that there will be an interference zone in all these scenarios. We have highlighted this using a pink patterned block. The interference would affect the users where users can see both the macro cells and the small cells. To manage this interference, ICIC was enhanced in 3GPP release 10 and further enhanced in 3GPP release 11. Here, let us introduce the concept of aggressor cell and the victim cell. Because the macro cell is transmitting at a far higher power as compared to the small cells, the chances are that a user that is camped on the small cell will experience interference from the macro cell. Hence, it's called aggressor cell, while the small cells are called victim cells. One of the other interesting things that happened in 3GPP release 10 was that carrier aggregation was introduced for the first time. I have explained it in the real 4G and 5G video. The main reason to bring this here is because of CA, there are multiple approaches for solving the interference issues in the victim cell. We will split the solution into CA based and non-CA based EICIC. One main thing to remember here is that if the UE is doing carrier aggregation, it is connected to multiple component carriers. The main one is called primary component carrier (PCC), while the others are called secondary component carrier (SCC). Let us start with the concept of almost blank subframe. As part of ABS, the aggressor cell silences for some time to provide protected resources to the victim cell. It will still have to transmit PSS, SSS, PRS, CSIRS, SIB1, paging, etc. for backward compatibility. Hence the use of term almost. The victim cell makes use of the silence time for many different things. The first is to schedule UEs in the victim cell, then to check its serving cell radio connection, measure its serving cell, and also for the UE in another cell to measure victim cell. ABS is sent to the neighboring E node B as part of load information message as shown here. We can show the use of ABS here along with another concept called cell range expansion or CRE. ABS can prevent cell edge UEs in small cells from being interfered with by the neighboring macro cell by having both cells use the same radio resources but in different time ranges or subframes. CRE, on the other hand, expands the coverage of a small cell so that more UEs near cell edge can access the small cell. In practice, CRE is realized by adjusting the trigger timing of handover towards or from small cells. A poor setting of trigger timing may result in handover failures or ping-pong handovers. This can then become MRO or mobility robustness optimization issue, and the MRO algorithm may try to put the new handover setting back to the old one. It is important that CRE works very closely with other mobility SON schemes. Let us look at CA-based ICIC here. Let's say that UEA camped on the small cell, the primary component carrier is the blue colored one, while the secondary component carrier is the red one. Another UE, UEB, is camped on macro cell and is using CA2. Its PCC would be the red one, while its SCC will be the blue one. To ensure reliable CA indication, UEA and UEB are both cross carrier scheduled. This means that the blue component carrier will schedule the red component carrier in the small cell and vice versa in macro cell. In release 11, almost blank subframes were enhanced as part of further EICIC or FEICIC. Instead of almost blank subframe, a reduced power ABS or RP-ABS frame was introduced, as you can see here. Again, the implementation can have static or dynamic algorithm for power reduction. While the static RP-ABS would be easier to implement, with dynamic RP-ABS, the small cell scheduler must communicate with the macro cell scheduler to exchange the amount of EICIC resource blocks and the corresponding required power reduction on each ICIC resource block. The receiver-based FEICIC approach relies on interference cancellation at the UE to eliminate the dominant CRS interference, which requires estimating the dominant interfering CRS at the receiver. Faris Al-Farhan explains this well on Frank Ryal's blog. See the second reference. Here are the references for further reading. The first three are relevant to this topic. So we hope we were able to explain this topic properly with the right amount of detail. With this, we come to an end of our SON series tutorials. Please let us know what you think about them. Thank you for watching and see you again soon. Goodbye.